These are the Unit 6A Module 3 notes on determining the number of solutions to a system of equations. What we're going to do is we're going to continue to solve some systems using our elimination process. We're also going to look at systems and determine whether or not there's exactly one solution to the system, maybe there's no solutions at all, or maybe there's an infinite number of solutions. And we'll determine what type of value we're looking at for those types of problems too. We're going to take a look at this first problem. You'll notice that the x's and the y's are different values. If we add the x's and y's together, nothing's going to cancel. So we had talked yesterday about multiplying one of these equations by a value. In this case, probably the number 2 would work out really nice. And whatever you multiply one side of the equation by, you have to multiply the other side by. But by doing this, what we get is by multiplying the left side of the equation by 2, we get 4x plus 10y. On the right side, 3 times 2 is 6. And you'll notice if we add the left sides of these bottom two equations now, the y's will be eliminated. They'll cancel out because we're adding opposites. So let's add the left sides and the right sides of these equations together. 3x and 4x equals 7x when you add them. On the right side of the equation, 22 and 6 equals 28 when you add them. Divide both sides by 7, you get x is equal to 4. There's our value for x. We're going to plug in x into one of these equations and we're going to solve for y. I happen to like this one right here, this 3x minus 10y equals 22, but it's your choice. If you use this equation, we're going to go 3 times 4 minus 10y equals 22. You're going to notice 3 times 4 is equal to 12, so we'll have 12 minus 10y equals 22. And to get y by itself, you're going to want to subtract 12 from both sides. What that's going to give us is a negative 10y on the left side of this equation. And on the right side of the equation, we'll have just a 10. And when you divide both sides by negative 10, you get your solution for y, which is negative 1. And we have our two solutions as an ordered pair, 4, negative 1. That's using our multi-step elimination that we talked about recently. Now, what do you do in a case like this next system of equations where we have things like 3x minus 4y equals 0 and 4x plus 5y equals 93? And it might be difficult to think of, what do I have to multiply negative 4 by to get a 5? Or what do I have to multiply 3 by to get negative 4? Sometimes the better process is to look at maybe this y term. We've got negative 4y and positive 5y. And maybe we multiply both equations by something so that the y's cancel. I know that if I multiply the top equation through on the left and right side by 5, I could make that 4y or that negative 4y equal negative 20y. But if I multiply the bottom equation on the left and right side by 4, I'm going to get 4 times 5y, which is a positive 20y, which should cancel the negative 20y I got here. So we're going to multiply each equation by a different value. But as long as we multiply it by the same value on each side, we're fine. So my top equation is going to become 15x minus 20y equals 0. 5 times 0 is 0. My bottom equation is going to become 16x plus 20y equals 93 times 4, which ends up being 372. Now you'll notice that the y's will cancel when we add the left sides of the equations together. I am going to have to add 15x and 16x, which equals 31x. And on the right side, I have 0 plus 372, which is 372. Divide both sides by 31, and you'll get your value for x. If you divide 372 by 31, we'll crunch this out over here. 372 divided by 31. And we get 12. There's your value for x. We're going to substitute 12 into either one of these equations. You can even type them into one of the original equations. I kind of like that. I'm going to choose this first one right here, this 3x minus 4y equals 0. I'm going to substitute 12 in for the x. It'll be 3 times 12 minus 4y equals 0. And we'll see what we get for y. 3 times 12 is 36. We'll subtract 36 from both sides. That'll get it away from the left-hand side of my equation. And I'll have, these are gone, negative 4y equals negative 36. Divide both sides by negative 4, and you get your solution, y equals 9. So our ordered pair is 12, 9. And that's how you can solve a multi-step elimination process by multiplying both equations by a different value. So now let's look at a scenario where we're going to determine how many solutions a given system of equations has. We're not necessarily going to find out what the solutions are, we're just going to determine how many there actually are. In our first scenario, we have 2x plus 5y equals 7 and 2x plus 5y equals 4. If we use this idea of elimination, we could multiply, for example, this top equation by -1 on both the left and right hand sides. And when we do that, the top equation would become -2x. -1 times 5y is -5y. And on the right side of the equation, 7 times -1 is -7. When we add our second equation to now our third equation, what you'll see is that 2x minus 2x is 0. 5x minus 5y is 0. So when we add the left sides of this equation, we don't have anything. We have 0. But on the right side of the equation, we have 4 minus 7, which is -3. If you get a nonsense math statement like this, 0 equals -3, 0 doesn't equal -3, what we say is that there's no solution. If you get a nonsense answer where you get two things that aren't equal to each other, it kind of means that our math has failed and we can't possibly get a solution. Let's take a look at this next scenario. I'm going to multiply the top equation in this one by -1 so I can get my 5y to cancel with a -5y. So similar to what we did last time, let's see what happens in this scenario. Top equation is -8x. -1 times 5y is -5y. -1 times 48 is -48. And in this scenario, when I add my x's, 4x minus 8x, or 4x plus a -8x, is -4x. Positive 5y will cancel with 5y. And on the right side of the equation, I have 24 minus 48, which is -24. It looks like I'm going to be able to solve this for x by dividing both sides by -4. I am going to get a solution for x, which is 6, and I could eventually plug that in and find a solution for y. I'm not going to go any further than this. I do have an answer for my problem. I do have exactly one x value, and when I plug it into either of these equations, I'll get exactly one y value. So if I get a value for x, that means there is exactly one solution to your system. In our next problem, we have 6x minus 2y equals 10, 3x minus y equals 5. I'm going to multiply the bottom equation by -2. And the reason I'm going to do this is, well, two reasons. One, if I multiply 3 by -2, I'm going to get -6, which will cancel the 6. And if I multiply -y by -2, I'd get a +2, which would cancel with this. So we're going to multiply the top, or I'm sorry, we're going to multiply the left and right sides by -2. In this equation, when I do that, -2 times 3x is -6x. -2 times -y is +2y. And 5 times -2 is -10. For right now, I'm going to kind of disregard this little equation right here. I'm not going to use this one right here. I am going to add our top and bottom equations. And when you do that, you'll see a 6x minus 6x, which is 0. -2y plus 2y is also 0. So there's nothing on the left side. And on the right side, I have 10 minus 10, which is also 0. If you get a true statement, but we haven't exactly solved for a variable, what this indicates to us is that there is actually an infinite number of solutions possible. If you get a true statement like this, what it usually means is that any value that works in the top equation will also work in the bottom equation. So we say that there is an infinite number of solutions if you don't get a value for x or y, but you do get a true math statement. Moving down to our bottom set of equations, we're going to have our 6x plus 3y equals 12 and 2x plus 3y equals 12. I think we'll get these y's to get eliminated, so I'm going to multiply the top equation by -1 on both the left and right sides. In doing so, will give me the equation -6x minus 3y equals -12. Now, in this scenario, when I add my x's, I do get -4x. The y's cancel, so I get 0, and the 12's cancel also. 12 minus 12 is 0. Now, is this a no solution problem? Well, no, I can solve for x. I still have an x in my problem. I haven't canceled out both of my variables. And dividing both sides by -4, 0 divided by -4 is just 0. So I do get a value for x. I can plug 0 into either equation, solve for y. It looks like I have exactly one solution because I did get a value for x. So just because you get 0 as an answer doesn't mean it's no solutions or infinitely many. If there's an x or a y attached with it, then we do have a solution. Over here, a little different scenario. Now we have equations that are in slope-intercept form. I'm going to multiply my top equation by -1 on the left and right sides. And doing so is going to give me -y equals -4x minus 3. Looking at my second and third equations, the y's cancel. Y minus y is 0 on the left side. On the right side, 4x minus 4x is also 0. 1 minus 3 is -2. 0 equals -2, again, is our nonsense statement. This means there is no solution to that particular system. In our last problem, same kind of thing. I notice that my 2x's cancel, so I do have elimination without having to multiply by anything. So I can add down my columns here. Y plus y is 2y. On the right side, the 2x's cancel, and I have 5 plus 1, which equals 6. Looks like I can solve this equation for y. I do get a value for y. I can plug my y in, get a value for x. So there is exactly one solution. So to recap what's happening here, if you get a value for x or for y, that means we have exactly one solution. If you get a true statement like 0 equals 0, but all the variables cancel out, there's an infinite number of solutions. If you get a nonsense statement where two numbers that are different from each other are said to be equal, that can't happen, so we say there's no solution. And that's how you determine how many solutions a system of equations has.